Hello friends, welcome to the lecture on engineering mechanics, and the topic of today is kinematics of particle. Now, the first topic in today's lecture is impulse. Now, what is impulse? Right now, to understand what is impulse, let us consider a small object. This is my small object, and this small object is acted upon by force F, and now the force F is acting for time t seconds, right? Force F Newton is acting on this object O for time t seconds, right? So if I draw a diagram, if I draw a graph, on the x-axis if I take time t in seconds, and on the y-axis if I take force F in newtons, right? So let us say my force is acting for time t seconds, right? Okay, so what is impulse? So impulse is nothing but force into time for which that force is acting. So this is a formula that you need to remember. Impulse is force into time, that's all. So if you remember this formula, that is sufficient for this complete topic of on impulse, and you can solve each and every problem. Now, so after knowing this formula, what else you will require to solve the problems is this thing, formula to remember, right? The first formula is impulse, that is equal to force into time. Now unit of impulse is Newton seconds, right? That is force into time. And second formula that you need to remember is second law of motion, that is Newton's second law of motion, that is equal to force is equal to rate of change of momentum, that is mass into velocity. Now if you just remember these two formula, that is sufficient for solving problems. Now how do you use this formula, right? So F is equal to, now rate of change of momentum, so I will write rate of change of momentum as mass into velocity, that is momentum, that is final, minus mass into velocity, that is initial momentum, divided by dt, I will write delta t, right? So in this problem, out of this four quantity, initial momentum, final momentum, force, this force is generally called as impulsive force, and time delta t for which the force is acting. So out of this four quantity, any one quantity will be missing, and that you will need to find, right? Now what is impulsive force? Let us say I have a cricket bat, right? This is a bat, okay, and while playing cricket I am swinging this bat, and by this bat I am hitting this ball, right? So initially what is happening is this ball was moving with some velocity v, right? This is initial time, right? This is initial. At the time of contact, this bat, right, this bat exerts a force F on the ball, and because of this force the ball leaves with some velocity v final, and this initial velocity is v initial, right? So this is final. Now at the time of contact of bat with the ball is, let us say, t seconds, right? So this four quantity is required: initial momentum, that is velocity if we are knowing, and if we know the mass of ball, that is initial momentum, final momentum is mass of the ball into the final velocity, right? And the time of contact is t, that will be given, and the impulsive force, the force exerted by the bat on the ball, is called impulsive force, right? Impulsive force is a force which is acting for a very short period of time, right? For example, bat hitting on a ball, that is one example of impulsive force. Second example is force inserted by the floor on the ball. Whenever a ball drops on the floor, the floor exerts some force for a very short period of time, and because of that force the ball bounces off, right? So instead of ball you can take any other object which bounces off, or even in case of tight slab, right? Whenever somebody slaps, so the time of slap or the time of contact of hand with your face is very small, but the force of slap is quite tremendous, and because of that you get some reddish mark on your face, right? So that is also an example of impulsive force, a force which is acting for a very short period of time, right? Now let us solve some problem. This problem solving is very easy. This is the one of the easiest topic of engineering mechanics, from where you can get a lot of problems, and the problems are not that difficult. It is very simple. Now this is sample problem. The problem is like this: a 630 gram of cricket ball strikes a bat with a speed of I have just misprinted 108, with a speed of 108 km per hour, and is hit back by a batsman with a speed of 144 km per hour. If the ball was in contact with the bat for 72 milliseconds, then determine the average impulsive force exerted on the ball, right? So this is a problem. Now let us draw some sketch of this problem, right? So this is a ball initially. Now mass of ball is 630. Okay, I'll just draw it a little bigger. This is a ball and this is initial phase, right? So it is 630 gram and it is traveling with the velocity of 108 km per hour, right? So now at the time of contact, let us draw a bat, right? This is a bat and this is my ball, and that bat is hit in this direction, swing in this direction. So at this point of contact there is a force F, right, which is impulsive force, and the time of contact is 72 millisecond, right? And the third thing that is given is final. The ball leaves at a velocity, this is my ball, and it leaves with a velocity of 144 km per hour, right? So this is a thing, and we know mass of ball. The mass of ball's initial and final will remain the same, 630 gram, right? So what we have to find is force, right? This force, the force by which bat hits ball, is unknown, right? So that is what we have to find. So let us consolidate all the given data, right? So given is, what is given is mass of ball that is 630 gram, and before solving the problem in this section, whatever the data is given, we will convert all the data into SI unit, so that there is no problem afterwards, right? So SI unit for mass is kg, so it is 0.63 kg, and V initial velocity of the ball is given as 108 km per hour, that is 108 km. Standard unit is meter per second, so kilometer, this is 1 kilometer, and 1 hour is 3600 seconds. So if you do all the calculation, you will get 30 meter per second. This is the initial velocity. Final velocity Vf is 144 km per hour, kmph, and after doing this conversion, 1000 meter by 3600 second, will get this as 40 meter per second, and delta t is, that is time of contact of bat with ball, is 72 millisecond. If we convert this into second, that is 72 into 10 raised to minus 3 seconds. So this data is given, and the formula that I want you to remember is second law of motion and impulse, right? So we are what we want to find is force, that is impulsive force. Just remember that impulsive force and impulse is different. Impulsive force is a force with the unit Newton, right? This is impulsive force, and impulse is equal to force into time. So in this and unit of impulse is Newton second, right? So in this formula, in this problem, we are asked to find what is the impulsive force, right? So its unit is Newton. Now this we have not been asked, so we will not use this. And the second formula that I told you to remember for the problems is second law of motion. So even if you remember second law of motion, that is sufficient. So I'll write second law of motion, that is force equal to rate of change of momentum, right? And that I will expand as mb into v final minus mass of ball into v initial, right, divided by delta t. Now putting all the values, this f is what we need to find. Now this mass and this is velocity, right? Now one thing that you need to take care is about the directions, right? Now since velocity is a vector quantity, this is vector, it has direction and magnitude, right? Now in our case, let us say this is our case, right? So here we need to define a direction for our case, right? So this is our x positive x axis and this is y axis. So this first velocity, that is initial velocity, is along the direction, so this is plus, and the second velocity is in the direction of negative x axis, so this is minus, right? So this thing is very important. Selection of coordinate axis. So next step is substituting the value, where mb is mass, that is common, that is we will take outside, that is v final minus v initial divided by delta t, right? So mass of that ball is 0.63 kg, v final is minus 40 minus v initial is 30 divided by delta t, and that delta t is 72 millisecond, right? So 72 10 raised to minus 3. So F we get is 612.5 Newton. And now why are we getting negative F? Because since our direction is positive in x direction, force is in the negative x axis direction, so F is in this direction, right? So the way to write answer is force is equal to 612.5 Newton and in this direction. So this is our answer. So that's all. That's the simple example for this topic, that is impulse or impulsive force. and we'll solve few more example in next videos. Thank you very much for watching this video. If you like my video, I request you to please subscribe to my channel and press the like button. And if you want to give any feedback, if you want to take new numerical problems, I request you to please comment it or send me a pic so that I can take that numerical in my video lecture and I'll try to solve it. Thank you very much friends for watching this video. Take care. Bye bye.